Okay. Now is it okay? Can you hear me now?
Yeah, I selected
Which picture?
11.5 discussion. I wanna do this.
Okay, first we will finish this.
Okay.
Right. So, right. So oxides are substances or compounds that contains oxygen and another element. For example, sodium oxide. What is the chemical formula of sodium oxide?
Sodium.
Right. Sodium oxide. So, sodium oxide. So, oxide O2 minus. Sodium means Na plus. So, sodium loses one electron and forms sodium plus cation. And oxygen in the outermost shell, it has it has 6 electrons, you know.
Yeah.
Right. So, to satisfy octet rule, it will gain 2 electrons and form.
So it's magnesium oxide.
This is sodium and this is oxygen.
So in the
So,
book,
in the book, okay, it doesn't matter. Magnesium, sodium, so all are metal. So, metal oxides are basic. So, they show the properties of bases.
metal.
Bases. So, sodium plus oxide. So,
For metals, they should put plus and for non-metals, minus.
okay, now shall tell me, sodium is a metal and this is a non-metal. So, normally, generally, metals loses electrons from their outermost shell and non-metals gain electrons
Gain electrons from that.
and form anion. So, this is cation, this is anion. Now, tell me the valencies here 1, here 2. Right. After that, by exchanging, we will write Na2O. So, this is what? Sodium oxide. Now,
Sir, what's the reaction, chemical reaction from this one?
we will see them later. Right. Now, we can get an element from the second group from the periodic table. Let's take magnesium. Okay. Magnesium, oxygen. Now, tell me, in the magnesium, we have 2 electrons in the outermost shell. So, magnesium will lose those 2 electrons and form magnesium 2 plus.
Magnesium.
Likewise, oxide. Now, tell me, here 2, here also 2. By exchanging, we will write magnesium oxide, MgO. So, this is magnesium oxide. Okay, let's take aluminium. Aluminium will lose 3 electrons and form aluminium 3 plus. Okay, likewise oxygen 2 minus. So, here 3, here 2. Right, by exchanging we will write Al2O3. So, this is aluminium oxide. Okay. So, this is how we write the chemical formula of oxides. Right? Now, you want to write this?
So yeah, alright.
Okay. Right. Now we are going to classify oxides into 4 categories. So this is just how we write the chemical formula, but we have separate chemical equations for producing these kind of oxides. Now we are going to look at the classification of oxide. What are they? Basic oxides. Right. The second one is acidic oxides. Right. The third one is amphoteric oxides. The fourth one is neutral oxide. Right. Now tell me. So what are basic oxides?
Basic oxides, metal plus oxygen.
Metal plus oxygen. So for example, generally metal oxides are basic. Metal oxides, right? So metal oxide show the properties of bases. So that's why they are called what? Metal oxide. Again, these acidic oxides are non-metal oxides. So acidic non-metal oxides show or exhibit acidic properties. So those are called acidic oxides. Now tell me, what is the term amphoteric mean? Amphoteric means?
They will react with both acids and alcohol.
Yes, that means they show both basic and acidic properties. Okay.
So what's the first definition of each?
Which here this one amphoteric.
Yeah.
So
Like basic oxides, what is the definition too?
basic oxides are the oxide that show the properties of basic. That's all. So if you are asked in the examination, you can write in that way.
So in the assignment research, you have to define in the following terms: basic oxide, acidic oxide, amphoteric.
Yeah. Oxides, basic oxide. So you can write like I told. Otherwise, you can write here. Wait. Define acidic oxide. Right, you can write like oxides that either produces an acidic solution upon in addition to water. That means it produces acidic solution. Okay, so for example, if you take sodium oxide and dissolve in water, it produces acidic solutions. Or in other words, you can simply write basic oxides are the oxide that exhibit acidic properties. So you can write in that way. Right, now amphoteric means what? They show both acidic and basic properties. Now neutral oxide means? They are neither acidic nor basic. They are neither acidic. Can you tell me an example for amphoteric oxide? For example, we looked at Al2O3, aluminium oxide. So this is an amphoteric oxide. A neutral oxide, H2O. H2O is an oxide, but it is not basic nor acidic. Okay? Right, we will come from the beginning. Right, here you can see basic oxides. So this is the reaction for producing magnesium oxide. Okay, so magnesium ribbon. So this is a magnesium ribbon. Have you seen magnesium in the laboratory? It's like a stripe of paper. Okay, folded stripe of paper, right? Again, magnesium ribbon is lit over a Bunsen flame and plunged into the jar of oxygen. It burns with a brilliant white flame, leaving a white ash magnesium oxide. Okay, now
Sir, can you tell me the definition of the correct definition of oxide?
oxides, right? Oxides are the compound which contain
Not oxide, basic oxide.
basic oxides.
Yeah.
Where is the question? Okay, first.
In the picture.
Okay. We will first study this chapter. After that, we can come to that assignment questions.
Okay.
When we explore the questions, we can write the answers. Okay?
Yeah.
Right. Now, here we have taken oxygen gas into a container. So, this container contains oxygen. Right? And we plunge magnesium stripe here, magnesium. Right? And we burn it. Now tell me, if oxygen is present inside the container, so it is an helper for combustion. So oxygen, we have already looked at the properties of oxygen. Where? In the last class. Do you remember?
Yeah.
So it's a helper of combustion. So this will burn. This magnesium will burn. And it will provide an white flame. So the flame will be like white and it will leave ash. So the chemical equation is magnesium solid plus oxygen. Why we put oxygen? Here magnesium reacts with oxygen. So if somebody is saying if you burn something means you make something react with oxygen. That is called burning. Okay. Without oxygen, you can't burn anything. So, in chemistry, if you burn something, it indirectly means you are reacting with oxygen. Oxygen. So, it will provide magnesium oxide. How did we derive this chemical, this one? So, when you burn, so this magnesium and oxygen will get energy, and here you will get magnesium 2 plus and O2 minus. So here 2, here 2. So by exchanging, this magnesium oxide comes. Okay. Now tell me. So if this is gas, and this is solid. Okay. Now here magnesium, only one magnesium. Here we have 2 oxygens. So we will put 2 here. Now tell me, here we have 2 magnesiums. So here we will put 2. Now the chemical equation is balanced. Okay. Right. This is like white ash. You know ash. What is ash? So after burning, something will remain. So that is called ash. And the color, normally the color of ash is black or grey. But here you will end up with white ash. Okay? Alright. When the magnesium is burning, you will observe a white fume. Okay? So here you can observe a white fume.
Yeah.
White fume. Right? You can write. So this is white fume and this is magnesium and this container contains oxygens. So this is the chemical equation. Did you study reactivity series? Have you written this?
Yeah.
Right. Before we study these things, I want to teach you reactivity series. So there is a series called reactivity series. So right. So this is called what? Reactivity series. So starting from the top, when you go to the bottom, the reactivity of elements will decrease. So from here to here, what will happen? Reactivity. Reactivity decreases. Okay. So from potassium to iron. So potassium, sodium, calcium, magnesium, aluminium, zinc, ferrum, Sn, Pb, H. So normally here we consider only metal. So these all are metals, but hydrogen is non-metal. But we include hydrogen in this series just to compare. Okay. So hydrogen, copper, Hg, Ag, Pt, Au. So there is an okay. You can. I'm just telling you, right? So we initially took magnesium. We initially have taken magnesium. After that, they take iron. This one. Okay. Again,
Hydrogen. So I didn't study about that.
you didn't study about this. If I teach you this first, you can be able to see this. Wait, I want to check whether reactivity series is included in your. Right. Here you can see this is the reactivity series. Okay, this is not included in your portion for this semester for this term, right? Right. So we can just go through it. After that, we can come to this point, right? So pulling it all together, the reactivity series. So we can use the result of the experiment. We would have already done some experiments.
I have this.
You have this portion.
This is the last chapter.
This is the last chapter. Can you? Where is that? If I the reactivity series before that 13.2.
So I'll send you one picture.
Yeah. Wait.
Just give me a minute.
13.2.
This is this one. So I send the
Right, we need to study 13.2 and 13.4, right?
So I have 13.2, yeah, and 13.2.
Right, before that, let's study this, then only you can understand that part. Right? So, shall we study this first? Then only you can understand that. Oxidation, reduction, you need these things. And then this part. What do you have any test on that chapter?
The last question.
Okay, I'll try to teach that. What is the page number?
11.5, page number 163. So I have reactivity.
Right, okay, now you can remember this series, okay? Potassium, sodium, calcium, magnesium, aluminium, zinc, ferrum, Sn, Pb, okay. Now they compare three elements. That is why I told you before studying this chapter, if we study this, you will quickly understand. So what the reactivity series says is, when you go along this direction, the reactivity of elements will reduce. That means potassium will readily react with oxygen. For example, if you take magnesium, iron and copper. So for the third element they have taken copper, right? Now we are reacting magnesium with oxygen. Magnesium solid plus oxygen. We will get MgO, right? Again we take Fe, right? Now tell me, Fe plus oxygen, what will happen? Iron can produce two cations. One is Fe2 plus and the other one is Fe3 plus. But the abundance is Fe3 plus. The abundance is Fe3 plus. That means Fe3 plus will exist more than Fe2 plus. So iron tends to make Fe3 plus. So here we have Fe3 plus and O2 minus. Now tell me, here 3, here 2. So by exchanging we get Fe2O3. So it will produce Fe2O3, right? Now tell me, when we try to balance the equation, here we have 2 ferrum, here we have, right, here we have 2 oxygen, but here we have 3 oxygen. Now here we have even, here we have odd. So we will multiply this by 2. Now we get 2 into 3, 6 oxygen. So in order to make it 6, we will multiply it by 3. Again, if you observe here, we have 4 ferrum. So we will put 4 here. Okay, this is how we balance the equation. Okay, right. After that, we take copper. So here, copper plus oxygen. So copper will produce Cu2 plus, and here we will have O2 minus. So 2, 2. So finally we will end up with CuO, copper oxides. Okay, right, now tell me. So when we consider these three chemical equations, now we initiate all these three equations at the same time, and we observe the time taken for the production of products. And what do you think about the time? This magnesium oxide will quickly form, and it will take more time to produce this Fe2O3. And for the formation of copper oxide, you will take more and more time due to the reactivity of these elements. So this is the reactivity series. So this series is used to compare the reactivity of elements. Okay, right. Now here we have taken the same procedure, right? So initially here we took oxygen in a container and placed magnesium and burned it. Again, so instead of magnesium, we take iron wool. So iron wool, this is iron wool, and we burn it with the help of oxygen. And what will happen is it glows bright orange. So you will observe a bright orange color. But when magnesium burns, you will observe white fume. But when iron burns, you will observe what?
White orange.
Bright orange, and throws out a shower of sparks, and it will spark. Have you ever seen this
So yeah, we tested it in the lab.
in the lab? Right. And black solid is left in the gas jar, that is iron 3 oxide, and this is black. What is the color of this Fe2O3? Black. So this is what? White. The color of magnesium oxide is white and Fe2O3 is black. So at the end of the reaction, you will end up with a black color substance, which is Fe2O3. Again, if you see here, copper is too unreactive to catch fire in oxygen, right? But it means when you go from here to here, the reactivity decreases. That means the tendency to react with oxygen for copper, Hg, Ag, P2, Au is very less, right? But when it is heated, but you can increase the reactivity of a particular element by heating, right? So by heating. But for these kind of things, you don't need to heat, by the way, right? Right. For example, if you take copper and oxide, so I will explain you using this here, right? In this apparatus, you take copper turnings and we heat it, right? So what will happen?
Yeah.
It will not react, but if it reacts, you will end up with a black color substance called copper 2 oxides. So this is what? Black color. This is also black. And the name of this is what? Iron 3. You need to mention the oxidation state. You didn't study about oxidation number also, right?
No.
Right. Now, okay. So this is iron 3 oxide. The name of this substance is iron 3 oxide. So we need to, if an element has more than one oxidation number, we need to mention the oxidation number in the substance within the parenthesis. So this is iron 3 oxide and this is copper 2 oxide. This is what? Copper 2 oxide. Okay. Right. The more reactive the metal, the more vigorously it reacts. That means, right, if you put magnesium, it will react slightly vigorously. But if you put potassium, if you react potassium with oxygen, it will vigorously react. Sometimes it may explode. It may explode. So you should avoid these kind of. Sometimes your teachers might not. If you put potassium into the water, it will explode.
Yeah.
Have you ever demonstrated it?
Yeah. Yeah.
Yeah. So magnesium. But if you put magnesium in a container of water, what will happen? It will move with the sound of like. Have you done this? With the sound, it will move around the surface of the water, magnesium.
It will be ground around.
Sorry?
Yeah.
If you put magnesium, so have you written this?
Yeah, I will do it.
And you better write this series as well, then only you can understand what we have done here. So we have compared the reactivity of magnesium, ferrum and copper with oxygen. So what will happen? This is quickly produce the product, and when you go downside, the time taken for the production of product will increase. That means the reactivity decreases. And you need to know the color of these substances. Magnesium oxide is white and ferrum oxide Fe2O3 is black, and copper oxide is also black.
Yeah, I can't see paper one down part.
This one?
Cu plus
What about now? Okay. Now, if you take this copper oxide and dissolve in water, it will not dissolve. So, it is insoluble in water. So, this copper oxide is insoluble in water. Some substances don't dissolve in some solvents. So, this copper oxide is insoluble in water, but it is soluble in acid. But soluble in dilute acid. You can write in this way. So, copper oxide is insoluble in water but soluble in dilute acid. Now, okay, right? So, after that you can see here the copper 2 oxide produced in the last reaction above is insoluble in water, but it does soluble in dilute acid. Now, this is dilute hydrochloric acid. That means in this container we have taken what? Dilute hydrochloric acid. And if we test the acid with blue litmus, what will happen? Acid turns blue litmus to red. Right? Again, here what we do is, right, litmus stays blue. Right, now if we write the chemical equation here, you can easily understand. Shall I erase?
Sir, give me this one. Sir, I just sir, don't say it. Yeah.
Right, now we are going to write a chemical equation. Right, now we take this copper oxide, CuO solid, and react with HCl aqueous. So what will happen? What will happen? What do you think?
CO plus
So this will come as copper 2 plus
copper
and
plus
O2
O minus.
O2 minus, and here it will become H plus and Cl minus, and this Cu2 plus will react with Cl and this will react with this. Now tell me, this Cu2 plus Cl minus 2 1, so it will produce CuCl2 and this H and oxygen H2O. Okay, right. This is the practical. Now we take in this container we take dilute hydrochloric acid and test with blue litmus. It becomes red. Okay, so this is blue and here you can see the red color, right? So after that, if you put copper oxide, so if you put copper oxide in the dilute acid, that is HCl, what will happen?
Will turn.
It will dissolve because copper 2 oxide is soluble in dilute acid. So it will, and this rod is used for stirring purposes. Okay, this is a rod, this is for stirring. Okay, for example, if when you are making tea, you stir the tea with spoon. Likewise, this rod is used for stirring. Again, here you can see copper 2 oxide dissolves in it when it is warm, but after a time no more will dissolve, like the case of sugar. So if you take some amount of sugar and dissolve in a container which contains water, if you add more salt, what will happen? Some will precipitated, some amount of salt will precipitated at the bottom.
Yeah.
Likewise, if you keep adding copper oxide, some amount of copper 2 oxide will remain at the bottom without dissolving. Okay, now you have, shall I erase this?
Yeah.
Right, here you take HCl, this is HCl, so you test with blue litmus. So initially it was blue and this portion has become red, and this is blue. Okay, right. Again, if you add copper 2 oxide, after removing this litmus, you add Cu2 copper oxide. What will happen? This copper chloride will form. This copper chloride will be formed. But you see, copper oxide is what? Base. Why? Copper oxide is base. Why? Because it's a metallic oxide. Metal oxides are base. And HCl is acid. This is acid. Now we are going to see the property of copper chloride. Now if acid and base reacts, it is called neutralization reaction. What is that?
Neutralization.
So the copper oxide is neutralized by HCl, right? So now you have mixed copper oxide, and here this is HCl. So at the bottom you have unreacted CuO. Unreacted CuO. Now if you put blue litmus, it will remain blue. What does it mean? There will be no effect, means it has been neutralized, and this is a neutral substance. So the purpose of doing this is to neutralize this base with this acid. Okay, so here it will remain as blue. So I am coloring this like this. You also can. We are adding blue litmus, right? Here also we have taken blue litmus, and it will, when the portion dipped in the acid will turn to red, and here it will not change. That means it is neutralized. So this is the chemical equation. Now let's try to balance the equation. Now tell me, can you balance it?
Yeah.
Balance. Here we have 2 chlorines, so 2, right? And this is the aqueous and this is liquid, right? Now here we have one copper, here also we have 1 copper. Here we have 1 oxygen, here also we have 1 oxygen. Here we have 2 hydrogen, here we have 2 hydrogen. So the reaction is balanced. The equation is balanced. Okay? Right, you can read further. Iron 3 oxide and magnesium oxide behave in the same way. They too can neutralize acid. So they are basic oxides. So this can be written for magnesium oxides and iron oxide as well. Iron oxides as well. Basic oxide belong to the larger group of compounds called bases. Okay. So basic oxide belong to the larger group of compounds called bases. So basic oxides mean they are bases. That's all. You can write this definition. Okay.
Basic oxides, they are basic.
Yeah. So they show the properties of bases. That's all. Now can you write the... So for example, we took magnesium oxide. So magnesium oxide plus HCl. What will happen? So this is solid, this is aqueous. So it will become Mg2 plus O2 minus, here H plus, Cl minus. So this will react with this and this will react with this. What will happen? You will end up with MgCl2 plus H2O. Likewise, if you take Fe, Fe2O3 plus HCl, so it will become what? Here Fe2 plus O2 minus, sorry, Fe3 plus. Here H plus Cl minus. So here FeCl3 and H2O. Try to balance the equation, the same scenario. Here we have 2 chlorines, here we will have 2 chlorines. Here we have 2 hydrogen, 2 hydrogens. Magnesium 1, again oxygen 1, hydrogen 2, right? This one,
This Fe2, so over here.
so here we have 3 chlorines, here we have 1 chlorine. Okay, but here we have 2 Fe, so we will put 2 here. Now tell me, it has become 6 chlorine, so here we will put 6. Okay, right. Now here we have 3 oxygen, so here we have 1 oxygen, so we need to multiply it by 3. Now what is the number of hydrogen? Here we have 6 hydrogen, here we have 6 hydrogen. Right, now acidic oxide. Now look how these non-metals react with oxygen. So for example, carbon is a non-metal, sulfur is a non-metal, and phosphorus is also a non-metal. Okay, so we burn means we reacts with, we make something react with oxygen. Okay, so here in this container we have oxygen, so this is carbon, burning carbon. Okay, so powdered carbon, we use powdered carbon, is heated over a Bunsen burner until red hot, then plunged into a jar of oxygen. So initially we heat carbon, after that we plunge the red hot carbon into the oxygen container, and what will happen? It glows with bright red and the gas carbon dioxide is formed. What will happen? Carbon solid reacts with oxygen to form carbon dioxide. Now tell me, carbon dioxide is what? Is acidic or basic?
Carbon dioxide acidic.
Acidic. Likewise, sulfur catches fire over a Bunsen burner and burns with a blue flame. When carbon is heated with oxygen, it will glows with bright red color. Likewise, magnesium, when magnesium it produces white fume. When Fe reacts, it will be bright orange. You remember?
Yeah.
Right.
Right.
Copper, it will only produce black color substances called copper oxide.
Substances.
Right. Likewise, here it glows bright red, and sulfur like blue color. Sulfur catches fire over a Bunsen burner and burns with a blue flame. So this will be blue flame. In pure oxygen, it burns even brighter. If the oxygen is pure, because you can't sometimes in the atmosphere, in the air, we have a mixture of gases. What is the abundant gas in the environment? 78% of nitrogen, 21% oxygen, and the remaining 1% is the carbon dioxide and other gases. Okay? Right. So, sometimes when you mix oxygen, some amount of nitrogen also will be present. But if you could extract only oxygen and use it, the blue color will be more brighter. That's what they are saying. The gas sulfur dioxide is formed. So, sulfur plus oxygen SO2. There is no need to. Actually, by default, the equation is balanced. Okay. Again, first, yeah. Yeah. Carbon plus oxygen CO2 gas. Sulfur plus oxygen SO2 gas. Likewise, here phosphorus bursts into flame in air or oxygen without heating. So it is stored under water. A white solid phosphorus pentoxide is formed. Okay? Phosphorus pentoxide. This is P2O5, but 2 P2O5 will combine together to form this compound. Phosphorus bursts into flame in air oxygen without heating. Right, so this is the chemical equation. P4, phosphorus is, this is the structure. For example, carbon we write like only C, but due to the structure of phosphorus, it will, 4 phosphorus will combine together as P4 and oxygen O2, and it will produce P4O10, that is phosphorus pentoxide. Okay, so when you balance the equation, here we have P4, so P4, and here we have 10 oxygen, so we need to multiply oxygen by 5. Okay, right. Now carbon dioxide is slightly soluble in water. Where do you find carbon dioxide? Have you ever drunk soda or soft drink?
Yeah.
So carbon dioxide is dissolved under high pressure in soft drinks. So this is the reaction. So it is acidic. So carbon dioxide is acidic, and when you dissolve, and it is dissolved in CO2, sorry, water. That's why we can prepare soda or soft drinks, right? The solution will turn litmus red. So you take carbon dioxide gas and you dissolve it with H2O under high pressure, and it will produce carbonic acid, H2CO3. H2CO3. So this is the way you have to remember this equation. CO2 gas plus H2O liquid. What will happen? H2CO3. This H2 come H2. This C comes here C, and here 2 oxygen, here 1 oxygen. Totally O3. So this is called carbonic acid. Carbonic acid. Okay. So this is CO2 gas, H2O liquid produces carbonic acid, H2CO3. So this is used in sodas and soft drinks under high pressure. Okay. Right. Sulfur dioxide and phosphorus pentoxide also dissolve in water to form acids. So they are called acidic oxides. Okay. So you can write the definition of acidic oxide like this. So from that, how you can write is acidic oxides are the oxides that produces acidic solution. Acidic solutions. So this is the definition. For example, here CO2 produces an acidic solution when added to water or upon addition of water. Upon addition of water. So this is the definition of acidic oxides. So acidic oxides are the oxide that produces acidic solutions upon addition of water. Right. Now, in general, non-metals react with oxygen to form acidic oxide. So, if a non-metal reacts with oxygen, it will produce acidic oxides.
Acidic oxide.
Now, amphoteric. Right. Amphoteric oxides. So, aluminium. So, I already told you, Al2O3 is the best example for amphoteric oxide. So, aluminium is a metal. Aluminium is also a metal. So, you would expect a aluminium oxide to be a base. In fact, both acidic and basic. But aluminium is metal. But we already studied what metal, but I used the word generally. Generally, metal oxides are bases. But aluminium oxide is an exception. So, it will act as acid and base. So, it is called amphoteric oxide. So, this is the equation. Al2O3 reacts with HCl to produce. I already wrote this, right? Did I write this equation? Okay, let's write on the board. Which one? Okay, I will explain.
So you wrote
Right, here amphoteric oxides, right? So we take Al2O3. So amphoteric oxide can act as both acid and bases. That means it can react with both acids and bases. So if you take HCl, an acid can react with only with base, but it cannot react with another acid. So here it's going to react with HCl. What will happen? So Al3 plus O2 minus, here H plus Cl minus. So AlCl3, AlCl3, this and this, and this and this, H2O. So when you can you try to equate this?
We have to put 2 in front of A and Cl.
Yes. So here 2.
And 3 after H2.
So here we have 6. So here we have 6 Cl. So 6 Cl and oxygen 3. So we will put 3 oxygen and 6 hydrogen. Okay.
Yeah, in the element three is after O, yeah. So why can't we put 3 after O?
Where? What did you ask?
Like after O3, yeah. in the
This one?
Yeah.
Reactor?
Why can't we put in the same way in the product also?
Here, I didn't understand your question.
In the reacting side, after O, 3 is there.
Okay, 3 is there.
Why can't we put the 3 after O in the product side also?
Here,
Yeah.
right. So if you put 3 here, this is H2O3. What is H2O3? Is that water? No. So when you balance equation, if you want to make any changes, you have to put in front of the chemical formula. That means you have to in front of the chemical formula. You can't make any amendments in the formula of chemical substances. Here, for example, here we have 2 aluminiums, but you can't put these 2 here. You can't put 2 here. Yeah.
So, if we give AL2O3 plus CHCl, I have to write it correct, yeah?
Yeah, you have to. Yeah. Yeah, you can predict the product in this way. Otherwise, you have to memorize. But by practicing, you will be familiar with it.
So, can you show the way?
Right. Here, this aluminium oxide means it can dissociate as aluminium 3 plus and O2 minus. Here, this HCl can dissociate as H plus and Cl minus. So here, this aluminium and this Cl forms aluminium chloride, and this H plus and this O2 minus produce H2O. Okay. Right. Again, this Al2O3 plus, now this is amphoteric oxide, mean it can react with bases as well. So I am going to take NaOH. So it will produce Al, no, Na. Na3AlO3 plus H2O. So there is no way to remember this equation. You have to remember this. Okay. So aluminium oxide, when aluminium oxide reacts with sodium hydroxide, so it will produce sodium aluminate. Sodium aluminate. This is sodium aluminate. This is what? Sodium aluminate. You have to remember this. So you can write this chemical equation in a piece of paper and paste it on the wall, so that you can again and again watch and memorize. Okay. Right?
Sir, for the voltage, I think there's no way to
Yeah.
differentiate
Yeah. So Al2O3 solid plus NaOH produces sodium aluminate aqueous. So along with the aqueous, this is liquid. So when you write the chemical equation, it is very necessary to mention the physical state. So sodium oxide is called amphoteric oxide. An amphoteric oxide will react with both acids and alkalis. That means amphoteric oxides mean they exhibit the properties of base and acid and bases. So it will react with both acid and base. So here the same compound aluminum oxide has reacted with HCl and NaOH. Okay, right. So this is the equation. You can just write again and again. You have to be familiar with it. So aluminum oxide react with HCl to produce aluminum chloride. So this is aluminum chloride and water. Right, again. So now tell me, when this substance react with acid, in this case it acts as base. In this case, this aluminum oxide acts as base. So here when it reacts with base, this is base, sodium hydroxide is base. You already know that. So in this case, it reacts as acid. Okay. Right, now neutral oxide. Again, zinc oxide, ZnO. ZnO is also an amphoteric. So for amphoteric, there are two examples, Al2O3, ZnO. Okay, zinc oxide. Right. The next one is neutral oxides. Okay. With that we can conclude. Right. Neutral oxides of non-metals are neither acidic. Neutral means they are neither acidic nor basic. For example, water. And there are some other examples also. So the gas is carbon monoxide. What is carbon monoxide? You know? Carbon monoxide. So this is carbon dioxide, this is carbon monoxide. So mono means what? Mono means, shall I erase this? Shall I erase this? Right. So here we have two compounds of carbon. So oxides of carbon. We have two. So carbon dioxide and carbon monoxide. So this is carbon dioxide. And this is carbon monoxide. What do you mean by di and mono? So di means 2, mono means 1. So here we have two oxygens. Right? So that's why we called it as carbon dioxide. And here we have only one oxygen, but we don't mention one. So we call it as carbon monoxide. And this carbon dioxide is acid, and this carbon monoxide is neutral. What? Neutral. Okay. Right. You know laughing gas, nitric oxide, N2O, nitric oxide. So this nitric oxide or dinitrogen oxide. So here you can see here we have two nitrogen. So this is dinitrogen oxide. So this is also neutral. This is also neutral. So you can see some oxides of non-metals. So non-metals basically neutrals are neutral oxides are oxides of non-metals. So this carbon oxide is also a oxide of metal, sorry, non-metal, which is carbon. So nitrogen is also a non-metal. So oxide of some non-metals are neutral. Okay, so carbon monoxide and dinitrogen oxides are neutral. Other nitrogen oxides are acidic. For example, N2O5. N2O5. So this is acidic. We will study them later. So nitrogen can form different types of oxides. So for example, NO, N2O5, N2O3, like that. So we will study them later. So only the N2O is neutral. The rest are acidic.
Acidic.
Right. Where is the wait? Right, now we will try to answer the assignment questions. Right. Right. Here, oxides. Can you see the screen now?
Yeah.
This is the question. Metals, non-metals react with oxygen. Completes the following. Yes. Non-metals and metals reacts with oxygen. So, I will write them on the board.
Sodium.
Sodium. We are studying everything without an order. That's the problem. Before I teach you this, I needed to teach you the reactivity series. They don't.
Can we study about reactivity?
Yeah, we should study. Then only you can understand these things. Can you give me a couple of minutes, please? I'll come. Okay. Right. Now for the first question. Right. When sodium reacts with oxygen, we need to know the observation and chemical reaction. Okay. So
Yeah.
when sodium reacts with water, we already studied when potassium, no, magnesium. When magnesium reacts with water, what will happen? It will produce white fume. But when sodium reacts with oxygen, it will produce an orange color, orange fume. It will react as orange color fume. So what is the chemical reaction? Sodium plus oxygen gives, it will produce two products, uh, sodium oxide and sodium peroxide, Na2O and Na2O2, but they have only asked one chemical reaction. Okay, let's forget about this sodium peroxide for the time being. So you can write only this chemical equation, right? So you can just here, how can you balance this equation?
Yeah.
Sodium oxide
We will put 2
in front of sodium.
yeah.
Now we have 2 oxygen. So here we need to put 2 again. Now tell me, here 2 into 2, 4 oxygen. So we need to put 4. Okay.
So can you explain this?
So sodium oxygen. It will produce sodium oxide. Normally sodium makes sodium plus cation and oxygen makes O2 minus cation. So when sodium reacts with oxygen, here 1, here 2. Okay. So by exchanging we can write like this, Na2O. Na2O. Right. So now tell me, here we have 2 oxygens. Here we have 2 oxygen. So I have put 2 here. Now we have 4 sodium. So I have put 4 sodium. So this is the chemical reaction. Okay. And when sodium reacts with oxygen, when sodium reacts with oxygen, it will burn in orange color. If I show you some videos, you can easily understand. Okay, now you can see the screen now.
Yeah.
Okay, so here you can see when sodium reacts with oxygen, here you can see the orange color fume here.
Yeah, I can see.
Do you want to watch that video so that you can memorize? So by illustration only you can. Let me share this sound as well. You share sound. Okay.
If we heat a sample of sodium metal, we see that it melts rapidly. Sodium has a lower melting point than lithium.
Now you can see here
The sodium
what color, what is the observation. So in this
It's
spoon,
orange.
so what is the observation? It burns with orange fume. So under observation you can write it burns with orange fume. What about magnesium? It react it
Orange. It burns with orange.
white fume. Okay, so
So sodium, can you please repeat the observation?
it burns with orange fume. So this is orange color. So this is the fume. You can see the fume here.
Yeah.
Right. Now let's look at for the magnesium. Magnesium reacts with oxygen. So here you can see white fume. Let's see this video.
Here we have a
So this is the what? Magnesium's types.
The magnesium.
ribbon of magnesium. Magnesium is a metal, has the properties of luster. You can see it's shiny. Oxide that's being
So you can
produced.
see here, what is this? White fume.
White.
So what is the product?
White.
White fume. And at the end you will end up with white ash, that is magnesium oxides. Okay, so
So
they
the observation is it burns with white fume.
white fume, and the chemical equation I already explained you how magnesium plus oxygen MgO. So this is solid, this is gas, this is also solid. So after writing the chemical equation you have to balance it 2 2. Okay. Right. Now this next one, where is that? Only we didn't study about sodium, but the rest we studied. You can try the questions. Now iron. What about iron? Iron. What is the color? We already studied.
Iron is like a
In the book it has been clearly mentioned. It burns with red or orange. Red, orange. Orange.
it burns with orange.
Orange flame. Or you can see the book here. In the book it's clearly mentioned. So you can see, wait, I will share the screen. So this is magnesium, so it is white fume, and this is iron wool, so it reacts, you can, here you can see bright orange or red. So this is bright orange. Bright orange. What is the observation? It glows bright orange. And after that you can tell about the color of the product also, and reminds after that it ends up with black solid. So that is the observation you have to write.
It glows bright orange.
And throw it like this, and throws out a shower of sparks, and a black solid is left in the gas jar. Inside the gas jar, finally there will be a black color.
So it glows bright orange and throws out a shower of sparks.
Yeah. And a black solid is left in the gas jar. That is observation. That is what you see. So observation means what? So at the end, what you see. Okay.
Yeah, black solid is left.
Okay. What about copper? Copper. Finally, the copper turnings will turn to black substance. That's all. There will be no flame or glowing like that. So finally, at the end, there will be copper 2 oxide, that is black color substance. So in the book you can see. So here this is for the copper. So this is the observation, and this is the chemical reaction. So the black substance, it's right. This is the observation. When it is heated, its surface turns black. This is the observation. Its surface turns black because of the formation of copper 2 oxide. Okay, right. And carbon we studied, sulfur we studied, phosphorus also we studied under acidic oxides. So under the acidic oxide you have the answers. Here Can you see? So here these are the answers. So carbon glows with bright red, and here sulfur with what, blue color, and here phosphorus also they have given the observation, and the chemical equations are also mentioned. You can write them. Right, here define the term. So oxides are the compounds containing oxygen and another element. Basic oxides, so basic oxides are the oxides that produces basic solutions upon the addition of.
So basic oxide.
So I wrote the definition for acidic oxide. So here you can just replace the term as basic, that's all. And the next question, you sent several pictures. Right, so the second question is, I'll just go through them because I have already.
Amma,
Right, so amphoteric oxide. So what are acidic oxides? Okay, amphoteric oxides. So without writing like that, amphoteric oxides means they can act as both acidic. You can write two definitions, right? So acidic oxide you can,
can I write that?
yeah,
Correct.
which one? So for acidic oxide you can write like this as well.
Take as
Yeah, that is the definition. So amphoteric oxides are the oxide that exhibit both acidic and basic properties, or that can act as both acid and bases, or it can react with both acids and bases. Right? Neutral oxides, you know, first just listen and understand. After that you can write in your own words.
yeah.
Right? Here neutral oxides mean what?
They don't react with acids. Okay.
They are neither acid nor base. You can simply write like that. And here, what is the formula? So this is dinitrogen oxide. Sorry, disodium oxide. So here I wrote like this. N2O means dinitrogen oxide. Why? We have two nitrogens. Likewise, NO2O means, or simply sodium oxide. So simply this is Na2O means sodium oxide. Otherwise you can put di also, but it's not necessary. Okay, sodium oxide. So Na2O,
Sodium oxide.
this is sodium oxide. And magnesium oxide, what is the formula? MgO. Now this is nitrogen dioxide. Nitrogen dioxide means nitrogen and there should be dioxygen. So the combining form di comes before oxide. So there should be two oxygen, NO2. So this is nitrogen dioxide. And this is dinitrogen oxide. So can you understand the differences between this and this? So here there are two nitrogens.
Di means there are two nitrogen and there is one.
One. Okay, so this is nitrogen dioxide and this is dinitrogen oxide. Nitrogen oxide. So the spelling is very important. And zinc oxide. Zinc 2 oxide means, what does this 2 means? The oxidation state. So Zn2 plus and oxide. So zinc 2 oxide means Zn oxide. So this is 2, this is 2. So by exchanging ZnO. What about the property? Is this amphoteric or neutral? This, no,
No, amphoteric.
amphoteric. What is the time now? Okay, we have run out of time. And what about dinitrogen pentoxide? Dinitrogen pentoxide. So mono means 1, di means 2, tri means 3. Okay, tri means 3. right? You can write separately. Tetra means 4, penta means 5. So now they asked to write the chemical formula of dinitrogen pentoxide. Dinitrogen pentoxide. Now tell me, here nitrogen and oxide, so NO. Now tell me the numbers. Now before nitrogen we have di, so we need to put 2 here, and before oxide we have pent. Pent means 5, N2O5, N2O5. Okay, and what is this? Al2O3, dialuminium trioxide, or simply aluminium oxide. So you can write aluminium oxide simply. You can write simply the aluminium oxide because that is general. So here you can write aluminium oxide, aluminium oxide. And you can try the rest also. If you have any doubt, you can ask. You can try the rest of the question by yourself. You can do.